Okay, hi guys. Hello and welcome. My name is Konstantin, and I am one of the 3D artists working for Chaos Group. And for the next 1 hour, we will be together playing with V-Ray for Maya. And I will be showing some of the older features of V-Ray for Maya, which are not used enough, in my opinion. And at the same time, they are really powerful tools that can save you time and effort. And also, I will show you some of the new features added to V-Ray 2.0, and I think you will have fun. So, without further ado, let's open Maya and see what I have for you. Okay, so V-Ray is a rendering plugin, but Windows Group like to call it a full-blown rendering solution. And this is because it can help you not only for material creation, light creation, and rendering, but it can help you during the scene preparation stages with your data management, with your assets, and all of that. Also, V-Ray is really useful in the post-production stages. Okay, and the first things I want to talk about is the tools for dynamic geometry creation of V-Ray. And by the dynamic geometry, I mean geometry that is created during render time. And I will focus my attention at render time subdividing, displacement, and proxies. And you will see how your workflows can be optimized and how you can save time and effort. Okay, so this is the scene I'll be working on, and this is the model that I have. And oftentimes you'll be in a situation like this one, when the meshes in your scene are modeled in a way that they need to be smoothed before the final shot is done. So right now, for example, the armor of my character right here, you can see that the armor has these hard edges, and I'm sure that this thing needs to be smoothed. And of course, you can always do a mesh smooth within Maya, but the result will be millions of polygons in your scene, especially if you're dealing with a lot of objects that have to be smoothed. And also, if the character was rigged, this might cause problems, and adding changes after that might be a problem. So with V-Ray, we have a better solution for this. So let me just remove the smooth modifier from the mesh, and I'll show you what I'm talking about. Okay, so with V-Ray you have the ability to add custom attributes to objects in your scene, to lights, to cameras, to all of that. And this is done in order to enhance the functionality and give you additional tools. So right now, if I select the shape node of this armor and go to attributes, V-Ray, I have the ability to add all these additional modifiers, but for this demonstration I'll choose the subdivisions. And here you can see that render subdivision surface option is activated. So this means that if I hit the render button during render time, V-Ray will smooth the mesh. And the cool thing about this dynamic geometry creation is that V-Ray is only creating the geometry in the bucket that is being rendered. And this means that this is extremely memory efficient, and you saw that the picture was rendered with no slowdown whatsoever. But the only problem that we have at the moment is that there's no control whatsoever of how many times the mesh is subdivided. And in order to get this control, I need to add one additional attribute, which is called subdivision and displacement quality. And with the subdivision and displacement quality, you have access to these two values, edge length and max subdivisions, which give you the ability to specify the amount of subdividing that is going to happen. And also, these additional attributes can be added to a single mesh, or they can be added to groups of meshes in the scene. Also, the view-dependent option will help you get smoother results closer to the camera, and less smooth it meshes further away. Okay, so this is the render time subdivisions. I can access it through these additional attributes, or I can also take advantage of the Maya smooth preview. So if I hit the 3 key on my keyboard, Maya will give me a smooth preview of the armor of this alien. And in the render settings of V-Ray, we have the checkbox called Render Viewport Subdivisions. After activating this option, I can render again, and you will see that again the mesh will be smoothed. This is quite useful for preview purposes, or it can be used for the final shot also. Like that. And okay, so the next thing I want to show you guys is the V-Ray displacement. And the same things that I told you about the V-Ray render time subdividing is also true for the displacement. I mean, only the polygons in the bucket that is being rendered are loaded into the RAM, and this makes the displacement quite fast and memory efficient. So you can see that the head of my alien character right here is quite low detailed and low polygonal at the moment. So I can just apply a material with the displacement to the head, and we can observe the result. Okay, I'll use this material, and if I show you the network, you'll be able to see the displacement modifier right here, and the displacement map that I'm using looks something like that. Sorry for that. I'll need to browse it. It is this one. Okay, so right now with this material applied to the head of the character, I'll hit the render button, and you will see what the displaced surface looks like, and also you'll be able to see the performance. Again, V-Ray will take a few seconds to calculate the global illumination, and after that it will start rendering the final image. So this is the displaced surface, and the cool thing about the V-Ray displacement is that you can use normal 8-bit displacements, or you can also take advantage of the 32-bit displacement maps created from ZBrush or Mudbox, and also vector displacement can be rendered. It is supported. I don't have an example for the vector displacement, but it's being rendered fine. And here's another interesting thing that I can do. I'll just unhide a layer with a sort of bridge. This one. And this bridge also has a displacement applied to it. So if I hit the render button, you'll be able to see what it looks like. Oops, sorry. Okay, so now V-Ray will calculate the GI, and after that you'll see the displaced surface. So I'm creating a grill-like displacement, but the problem right now is that I don't want to see these excess parts of the geometry. I want to see only the grill and not these flat faces down here. And of course you can create this by using opacity masking, or you can model the grill as you want it, but this might take a while. So we have a better solution, and it's called the water level. So if I expand the options of the displacement of this surface, you will see that there's the checkbox called Enable Water Level. I'll activate it, and after that, with the water level value, I control how much of the geometry will be cut out during render time. Right now it's set to 0.02, and I'll just hit the render button, and you'll be able to see the results. So you can see that all the unnecessary parts are cut out, and this is actual geometry. And of course, if I place two surfaces one on top of the other with reverse normals and with the same displacement map, I can actually create objects with thickness. And let me show you another really cool example of the water level. Okay, so here I have this these two planes actually, and they have textures applied to them. And when I hit the render button, you will see that thanks to the water level, these two forks are created immediately. So this is a really powerful tool that can help the modeling guys quite a bit, and in specific situations you can save a lot of time using that. Okay, and right now I want to focus my attention at probably the most powerful tool for dynamic geometry creation, and it's called the VRay proxy. So to demonstrate the capabilities of the proxy, I will first open a scene with an actual model, and after that I'll show you how to convert it into a VRay proxy. Let me find the scene. And it will take a while before the scene loads because I have more than 10 million polygons right here. And you can see this is the model. And I will activate the wireframe so you can see what the polygons look like. And I have approximately 10 million polygons in that scene, a lot of details. Everything is smoothed and looks great. But if I try to rendering this model and for example, animate it or render 100 of these models, I'll probably run into problems. I will run out of memory, and the renderer might crash. And this is why the VRay proxy was created. What it will do is save the information for all these polygons on the hard drive, and after that, during render time, only parts of the geometry are going to be loaded into the memory. So if I want to convert an object from this scene right here into a proxy, I need to go to Create VRay and click on Create Proxy. And these are the options of the proxy. I can export animations also, but I'll talk about that later. So I have already converted this object into proxy, so let's go back to our alien scene and test it out. Okay, this is the same scene. I just unhide the layer with a proxy, this one. So this is what the proxy looks like. This is just a rough representation of the model, but at least you get a representation. You don't get this bounding box. You can get a general feeling of where the object is located in the scene and what the shape of the model is. And of course I can specify how much polygons will be representing the model in the scene. If I hit the render button, you will see that the same exact model will be dynamically created in front of your eyes. And the speed in which this robot is rendered is just amazing. Okay, but I can go even further. Let's say I want to create an animation with a lot of proxies. For example, a lot of these robots flying around in the scene. I'll just unhide the other layer with a curve, and when I hit the play button, you will see all these proxies emitted from this emitter down here. And these are actually the same exact robot models, so I can stop the animation like this and choose a nice view of the composition and hit the render button. And again, VRay will calculate the GI, and after that we'll render the final shot. And I can assure you that this is exactly the same model, and I'm not using any tricks. There is no displacement here, no bump mapping, no nothing, only geometry. Okay, and that's great, but let's say I want to animate my robot model. For example, I want the tentacles of the robot to be moving like this, and render the same thing out. Actually, this is possible because, as I showed you earlier, the VRay proxy can export animation, and it can also export velocity information. which will give you the ability to render animated objects with motion blur after that. So right now I'll open another scene. It has the same model converted to proxy, but this time if I hit the play button, you can see that the tentacles of the robot are moving. And the imported mesh will loop this animation so I can have a consistent motion throughout the whole thing. So I have actually rendered this animation already, rendered an animation of all these robots flying around, and I can show you what it looks like. And for the purpose, I'll use PD Player, which is another software sold by Chaos Group. It's a sequence player. And this is the animation. If I hit the play button and let me make it a little bit brighter, you can see all these animated proxies flying around in the scene. And if I stop it like that, you'll be able to see that this is the same exact models with all these details. And everything was rendered with no delay whatsoever. Okay, but at the moment these are instances, so let me show you a scene where all the proxies are unique models. And I had around 60 or 70 million polygons in that scene. And this composition is a model of a town demolished by a volcano, and since I couldn't open all these polygons at once, I had to convert parts of the geometry to separate proxies, and after that they were imported right here. So if I hit the render button, you will see that the rendering immediately starts, and after the GI is calculated, we will take a look at the amount of details that we get. Okay, so the details right here are just insane. We have a lot of details. We have all these stones on the ground. Everything is geometry, no displacement mapping, no bump mapping. Only dynamic geometry. And right now if I open the task manager of Windows, we'll be able to see the memory consumption of V-Ray. And at the moment, V-Ray is using 1.5 gigs of RAM approximately. And you can see that even if you had 2 gigs of RAM, you will be able to render the same thing out with all the 60 million polygons in it. Okay, so I think you get the idea. I'll stop the rendering right there and continue further. So right now, from the dynamic geometry, I'll move on and talk a little bit about light sources. And you probably know that V-Ray has all these area light sources, and also it supports all the Maya light sources. But there are a couple of V-Ray specific lights that are extremely useful and that address specific problems. Let me open. I'll again use the scene with the alien and show these specific light sources. Okay, so sometimes when you're doing a 3D setup, you have to emit light from a surface of an object. And right here I have a tube object which needs to be emitting the light in my scene. And you know that if you want to achieve this effect, the common approach will be to assign a self-illuminated material to the object itself, and after that rely on the indirect illumination rays to hit the surface and bring light into the scene. And this is exactly what I've done right now. First of all, I have a surface shader with a color intensity of 30 assigned to the tube object, and also I have activated global illumination. So let's choose a nice view of the composition and hit the render button. And of course we get light into the scene, but since my GI settings are quite low at the moment, you can see all these artifacts. We have splotches all over the place, not a nice shadow casted by the objects, and also the context shadows are really washed out and blurry. And this is not something you want to have, especially if you're dealing with animations. This whole thing will flicker and it will be nasty. Of course, I can go on and start increasing the GI settings, but at the end, the render times will become excessive. So I'll just use the history button here in the V-Ray frame buffer and save the image for comparison. So for this kind of situations, V-Ray has a really nice and simple solution. It's called the mesh light. And in order to convert this mesh to a light, I need to go to create V-Ray mesh light and say turn selected into lights. Immediately after I do it, this object gets this light modifier applied to it. And in the light modifier section, it is obvious that we have light color intensity multiplier. We can choose between working with Maya Maya default units or with physically accurate units like lumens, watts, or whatever. After that, we have subdivisions which are controlling the quality of the shadows and the light itself. And also I can use a texture, plug it in this slot right here, and the texture will affect the light coming from the object. So with the mesh light, let's go on and render the picture again. And of course it will take longer to render, but the quality will be much better. And I want to point out the really nice shadows casted by the object. And the blurriness and the size of the shadow is of course entirely dependent on the size and the shape of the mesh that's emitting the light. And this is extremely useful tool, especially if we are talking about animations, because the only artifact that you might get when using the mesh light is this fine noise. And if I want to fix the noise, the only thing I have to do is to go to the settings of the mesh light and just increase the subdivisions. I will just increase the subdivisions to 20 and render a region. And you can see that the noise is completely gone. So the control over the mesh light is quite straightforward. Another cool thing about the mesh light is that it does not require global illumination in order to emit light. Like right now I can turn off GI, and when I hit the render button you will see that again there will be illumination in the scene. And this is because that's a direct illumination coming from the surface of the object, not a global illumination. And of course, if you want to create caustic effects, for example, this is possible again with the mesh light, and the caustics will be emitted from the surface of the object. Otherwise, if you're using the alt approach, you would have to create additional light sources and fake the caustic effect. And this is the mesh light with good quality and without global illumination whatsoever. So let me turn down the subdivisions of the mesh light, and I want to do one last thing. I want to plug a texture here in the texture slot of the light source. Immediately after I do it, you can see that the light coming from the mesh is obeying the ramp texture that I have just applied. And to get more of a yellowish type of light from this side and more bluish light there in the back. Okay, and there's one more really cool light source that comes with V-Ray, which is called the dome light. It is similar to the mesh light, but addresses a different kind of problem. And let me just hide the tube, and let's say I want to to create a IBO type of setup. I want all the light in the scene to be coming from the environment. In situations like this one, I'll probably go to the environment options of V-Ray and plug a texture here in the GI slot. So let's do it real quick. I'll choose a bitmap and load an HDR image. And the HDR image looks something like that. And you can see that it has quite a big dynamic range. So again, I'll need to rely on the GI rays to hit the environment and bring light into the scene. So let me turn on GI and hit the render button. Okay, so we get light into the scene, but again, since my GI settings are quite low, a lot of splotches are appearing, and we don't have nice shadows, no contact shadows, and everything is washed out. So in order to fix this, the best solution would be to use the V-Ray dome light. Let me go on and create one in my scene. I'll go to create lights and choose the V-Ray dome light. It doesn't really matter where I place this gizmo, because the dome light will create this imaginary dome around all the objects in the scene. So I can place it right here and it will be fine. And for the dome light itself, I need to use the same exact texture. I think it's this one. No. It's this one right here. So I'll use the same HDR image. And when I hit render, again the GI will be calculated, and after that you'll see a perfect illumination coming from the environment. I don't have any other light source in the scene at the moment. Okay, so these are the dome light and the mesh light. Again, as with the mesh light, the dome light emits direct illumination, and also it can produce caustic photons, and you can create caustic effects with it. Okay, so right now I want to talk a little bit about render elements. So let me open another scene. And as you probably know, V-Ray is a biased rendering engine, and this is why you get access to all the to this rich palette of render elements. And in this specific setup, I've used a lot of them right here just to show you the effect. And when I hit the render button, even through the V-Ray frame buffer, while the picture is being rendered, I can take a look at what the different render passes look like. So this is my beauty pass. And I can choose reflection, for example, and you'll be able to see your reflection pass immediately. Also, you can create Z-depth passes and all sorts of render elements that are extremely useful in the post-production stages. But even though you have access to this rich palette, you might still want to create custom render elements. And oftentimes people have been asking me, why is there no ambient occlusion pass in that list? And the answer for that is simple. You can create a custom render element, apply a V-Ray dirt texture to it, and you get ambient occlusion pass, basically. So let me do that real quick, and you will see the result. I'll create an extra texture render element, and the extra texture render element gives me the ability to plug a texture in that slot. So I will choose the V-Ray dirt and just increase the radius of the dirt a little bit. So now when I hit render, you can see the same picture is appearing, but this time if I expand the list of render elements, down at the bottom you can see that our V-Ray dirt is calculated, and I've just created an ambient occlusion pass. And you can be really creative with this tool, and you can create all sorts of render passes. You can create masks, you can create also facing ratio render element if you want to, and all the Maya render nodes are supported. Okay, so even though you have access to this rich palette and you also have the ability to create custom render elements, in V-Ray 2.0 we decided to add a new something new there also. So let me open a nice example. Not this one. Okay, so this is the example scene, and in this scene we have a lot of light sources, and let's say I want to tweak the intensity of these light sources separately in post. And now with V-Ray 2.0 you have the ability to do it, and this is done through this new render element called light select render element. How to use it? You just have to add the light select render element in this list, and after that in the outliner you will see this selection set created by the render element itself. And if I drag a couple of lights underneath this selection set, the contribution of these lights will be extracted by the render element, and you'll be able to tweak the intensity, hue or saturation of these lights in post. So if I go to my render camera right now and render, so this is my beauty pass, but if I open the list of render elements, you'll be able to see this light select render elements, and for example I want to see the contribution of the street lights only, or let's say I want to see the contribution of this left adverts right here, or I can see these backlights in the background. So at the moment I've divided the whole thing into several different passes, and I'll actually stop the rendering right here because I have rendered the picture already, and I can show you what kind of effects you can achieve afterwards. So I'll open the rendered image in PD player, and these are all the render elements in different layers right here. So first of all I can start turning off lights like that. For example, I might want to turn off the street lights like that, and right now you can only see the contribution of the inside lights and these advert lights. Another cool thing that I can do is start changing the exposure of the light sources, of the layers rather. And even if you're using Nuke, you can animate this and create an animation with only rendering one frame. And I can do the same thing with these left adverts. I can tweak their exposure also. Okay, so this is the light select, a really powerful tool, really useful. And right now I will continue by talking about the real-time rendering solution, which comes with V-Ray 2.0. It runs on GPUs or on your CPU, but before that, just because I forgot to mention something about the proxies, I will go back to the proxies for a little bit, and after that I'll show you the RT. So let me see. So yeah, I had this model in ZBrush, and this is what it looks like, and it has more than 10 million polygons. And let's say I want to render the real thing in Maya, for example. I don't want to convert this to displacement. I want to import the actual geometry and render it out in Maya. And probably I'll have a hard time doing so with the whole character, because Maya won't be able to open and load all these polygons. So if I cannot load the geometry in Maya, I can still convert it into proxy and after that use it. And this is done through one external application that comes with V-Ray, and it's called Apply to VR Mesh Converter. So with the help of this command prompt, I can grab an OBJ file and convert it externally to a proxy file. And I have done this already, so I have this head VR mesh, and this head object has never been inside of Maya. it was converted externally. So let me open the scene with the proxy. And this is really cool because you can implement it in your pipeline. You can export objects straight out of ZBrush, and after that render them in Maya with full quality. So this is the proxy of the head created externally, and if I hit the render button, you will see the geometry interactively created. And this is the same exact model. Okay, so this was a little bit off topic, but I just wanted to point out this workflow, extremely useful, and especially for big company pipelines and such. Okay, so right now let's continue talking about the RT. And for the purpose, I will use this simple scene, and after that I will show you a couple of production examples of the RT running. So in the V-Ray options, you can clearly see that in V-Ray 2.0 we have this new tab called RT Engine. Here is where you can find all the RT specific options, like trace depth, max render time, max paths per second, so on and so forth. The RT is a progressive path tracer. It shoots rays from the camera, it's unbiased renderer, and it has the ability to give you immediate feedback of what is going on in the scene. And if I want to start RT within Maya, I just need to hit the IPR button up here. And you can see the RT running. It's giving me immediate feedback. I can rotate the camera, I can change light positions, light intensity, I can play with the V-Ray physical camera, and the RT will give me immediate feedback. So another really cool thing is that the RT is really quick at rendering blurry reflections, for example, something that tends to be quite slow with the production renderers. So let's say I want to create a car paint shader and apply it to the car. First of all, you probably know that the car paint shader is made out of two layers. It has a base layer, base metallic paint, and on top of that it has a lacquer layer. So let's start by creating the base layer, and after that I'll create the lacquer. I'll use a V-Ray material for the purpose, and for the diffuse color I'll set it to black, and for the reflection color I'll set the color of the car, let's say blue. And also my base layer needs to be blurry, so I can decrease the glossiness of the reflection, and you can see that the RT is handling blurry reflections extremely quickly. And let's say that this is my base layer of the car paint, and right now I want to work on the coat layer, or the lacquer rather. So again I'll use a V-Ray material applied to the body of the car. Again, I'll choose a black color for the diffuse, and I'll make the reflection color almost 100% white. And right now I have my base and my coat layers, and the only thing I need to do is to blend the two materials together. And probably the best way of doing it is by using the V-Ray blend material. So let's create a V-Ray blend material and plug the two previously created materials to their corresponding slots. After that I'll apply the blend material to the car. And the problem right here is that I'm blending the first and the second material with this gray color. This means that if I set the color to black, I'll only see the base, and if I set it to white, I'll see the coat the other way around. But I actually want to see more of the base layer if I'm looking straight at the surface, and I want to see more of the coat layer if I'm looking at the surface in an angle. So I can achieve this effect by using a V-Ray texture called the V-Ray Fresnel. So let me find it. So here it is. And the V-Ray Fresnel texture will create two different colors depending on this index of refraction, black color and white color. So I'll use the Fresnel texture in the blend mount of my material, and right now I've created a quite nice looking car paint shader. And right here, by changing the index of refraction, I can make my coat layer more visible or less visible. So for example, if I set the index of refraction to 3, my coat layer will be more visible, but still I'll see more of the base layer straight, looking straight at the object. Okay, and you just saw how the artist can give you immediate feedback when creating materials, and how interactive this whole process can be. But actually in V-Ray 2.0, if I want to create a metallic paint, I don't have to go through this whole process over and over again. We have the V-Ray car paint material ready and prepared in advance for you as a complete shader. So if I create the car paint material right here in the scene, so sorry for this, guys, my froze for a little while. My computer froze actually. Okay, so let me restart Maya, and I'll immediately open the scene and work from there. Okay, so basically the car paint material is a blend material, and you don't have to do any blending, so it has all the layers in it. Let me quickly open the same scene and I'll show you what I'm talking about. Okay, so I want to assign a new material to my car, and I'll choose the car paint material. And this is what the car paint material options look like. Let's fire up the artist so we get an immediate representation of the material, and I'll briefly explain what all these options do. So, okay, the car paint material has a base layer, it has a flakes layer, and it has a coat layer. And yes, it has the flakes layer, which is extremely useful, because otherwise, using dot approach, if you wanted to create these flake effects, you'd have to use procedural maps, blend a lot of materials together, and still the effect won't be that good. So right here, I can change the color of my base layer, I can change the color of the flakes, or if I want to turn off the flakes completely, I can set the flake density to 0. And sometimes you might want to do that because some of the older car paints, they don't have flakes at all. And on top of that, we have the coat layer, which is again representing the lacquer. And the cool thing about the car paint material is that it's not only useful for creating metallic paints. You can create all sorts of materials if you're creative. So for example, I have created one material in advance, so I'll really quickly apply this material to the ground. And you can see that again the car paint material is used, and the flakes are representing these particles in this artificial stone-like material. So this material can be used even for architectural purposes. You don't have to use it every time for car paints. So you can see it better like that. Okay, and this was just a simple example, but right now let me open a production example scene, and you'll be able to see the performance of the RT. Okay, so here is my setup. I've created these simple models of buildings and this really nice model of a car. It has all the materials assigned to it, and it's ready for a final shot. So let me just fire up the RT and you'll see the performance. And keep in mind that I'm only using one 8-core processor right now, but still the interactivity is quite good. So this is the RT rendering the scene out, and if I rotate the camera, you will see that the picture in the frame buffer updates automatically. And many people have been asking me if they can use the RT for production purposes. And the answer is yes. If you wait long enough, the RT will clear all the noise, and you have a perfect picture. You can use it. If I want to, I can save the picture on the hard drive and use it. And another cool thing is that the RT can also be used for animation renderings. So I can render each frame by specifying this max render time or this max paths per pixel, and after the RT hits the max render time, it will save the picture on the hard drive and it will continue with the next frame. And also effects like motion blur and depth of field are supported. And in fact, you can see that I have depth of field activated here in my scene and the background is blurred out. Okay, and here's another example of the RT. I have the same model here, but the setup is a little bit different. So this time I don't have modeled environment, I have an HDR image instead. And you can see that with the HDR image, the performance is again great. And the cool thing right now is that if I select my texture, I can start rotating it and the RT will update automatically, and this is extremely useful. For example, if your supervisor is next to you and he wants to see different HDR images and how they are affecting the scene, you can really quickly change the HDR image, rotate it around and see what the result will be in the final shot. And right now I want to briefly show you the RT running on GPU. I will use the same model of a car, and you will get a feeling of what the performance differences are. Okay, so this is the same exact model, but the HDR image in the background is different, and I also have a couple of light sources that are reflected by the car but are not visible directly to the camera. But this time, instead of using the CPU RT, I will change the mode to OpenCL, which will use the resources of the video board and render the picture. And it will take a while till the textures are loaded, and immediately after that you can see the representation created by the GPU. I can rotate the camera and it's fully functional. And this scene is quite simple. It has only the car model, the ground plane and the HDR image. But if I open a slightly bigger scene, you will see the performance improvement, and it's quite amazing. Okay, so here we have a bigger scene with high detailed environment, with the car, with the V-Ray physical sun and sky system, and I'm rendering through the V-Ray physical camera. And also the resolution that I'll use will be 1200 by 749. So let's hit render and see what the performance is. Of course, the RT will need a couple of seconds to load all the assets, all the textures in the memory of the video board. And after that it will give us feedback of what is going on in the scene. So let me make it a little bit brighter. So you can see it better. And even if I rotate the camera, the RT is refreshing immediately. And you can clearly see that this can be used for production purposes, because just for a couple of seconds almost all the noise is gone. And there's another cool thing about the RT, and is that the RT can do stereoscopic rendering, and you can get real-time stereoscopic images and preview them with your cyan magenta glasses, for example. So let's open a scene that will show you the effect. Okay, so I'll just adjust my resolution, and in the RT settings I'll enable stereo vision. And I have the ability to tweak my eye distance, and of course the stereo image is also dependent on the position of the camera and its target. Okay, so you can see the two images side by side, and if I rotate the camera, the two images will be updated automatically, both of them. But the cool thing is that here in the frame buffer you have this this button which lets you preview the image with your cyan magenta glasses, and you can get the feeling of how the image will look after the whole thing is rendered. And the thing that I want to finish my presentation with is the RT used for animation. And actually I've used the RT running on GPU to create this animation. It's this one. I'll use PT Player to preview it. So here's a complete animation rendered with the RT running on GPU. And you can see that it supports motion blur, and also each frame took 0.2 of a minute, like 12 seconds per frame, and the quality is quite nice. And also for the motion blur I'm doing 10 geometry samples. So if your video board has enough memory, you can do it, and it's really quick. Okay, so I think that's all that I wanted to show you guys. Thank you very much for the attention, and if you have questions, I will be available afterwards here at the booth, and I'll be answering all types of questions. Thank you.